Saving a game in Unreal Engine is pretty straightforward, but you kind of have to understand the logics behind it, and you have to do everything in a specific sequence per se, so that you're properly saving the file and then you're loading the data and using that data that just got loaded. Let me explain the process flow of saving a data in Unreal Engine. I'll be very quick, I promise. So you have your player data that is stored in arrays, components, blueprints, etc. It's all a different type of blueprints and the variables that's within it. Now, in Unreal, this is considered to be non-persistent data. This means that all of the data that you have manipulated throughout your entire game, let's say your health values or your checkpoint data or your player location data, all of that does not get really saved because it's non-persistent files, all these blueprints. So when you go to a new level, it's going to be like starting a completely brand new game from scratch. This is why we don't use non-persistent types of files to save and store data. Unreal has a built-in system that allows us to carry data from one level to another level. The system that Unreal uses to store data from one level to another level is called game instance. Now, game instance is persistent, which means any manipulated data like your player's health or player location, if you were to place it inside of the game instance, then it will carry from one level to another level. But here's a warning. If you were to turn off the game and turn it back on, or close the application and turn it back on, game instance is not going to remember all of that stuff. It only carries the information from one level to another level. And this is where we're going to be using the third type of file, save game file. This is actually another type of blueprint per se. Using this same game file, we are able to actually create a local copy on your computer with all of that manipulated information and save it locally. So next time when you close the application and load, we can actually use the game instance to go to the save game file and then collect all of that data and update and distribute all of that data to all of our other non-persistent files. This is the process flow that we're going to follow. First, we're going to create a save game file. Using that save game file, we're going to create a save game object in the game instance. So this way, the game instance can actually keep a reference to the save game file and then read and write information to the save game file whenever we trigger it. Now we take all of our player data information or world data information, whichever information that you're manipulating inside of the game. We're going to take all of that information and we're going to send it to the game instance. In return, the game instance is now going to update the save game file with all the information inside of it, like the player data information. We're going to save the game. That's how simple it's going to be. Now, again, this is a very logical process. First, you need to define the save game file and all the variables that you want to save. You need to define the save game file with all of that variables. Then, using that save game file, you're going to create a reference to it in our game instance. And then whenever the player's data get manipulated, we're going to send that information to the game instance every single time. And the game instance is going to then communicate with the save game file because we have already created the reference here. And we're going to update the save game file with all the new information that we have received. And we're going to save that as a local file in our computer. So this is the entire save game process. And in a load game, we're just going to go ahead and get the information from the local save file using the save game file. And then that information is going to be sent to the game instance. And using the game instance, we're going to go ahead and retrieve all of the data and update the player's data when the game begins. This is all it takes to create a save game and load game. This is the concept of it. If you understand this concept, you should be able to save your game and load your game whenever and wherever, however you like. So let's go and see how this works in the game. So let's start with our game instance. So in my content drawer, let's go to the core folder. Let's go ahead and create a new folder for this. I'm going to name this game instance. And inside of here, I'm going to go ahead and create a new blueprint class. And here under all classes, I'm going to search for game instance. And I should have a game instance here. Let's select it and name this as GI for game instance underscore your game name. So I'm just going to name this like Necrobit. Let's go ahead and save that game instance. And now we need to set this game instance as the instance that this game will be using. So if you go to your edit project settings, up here you can actually search for game instance. You actually can see that there's a default game instance class that comes with Unreal Engine whenever you create a project. This is what's going to be, and we don't really have access to this. So this is why we create a new game instance file. So if I click on that, I can actually see my GI Necrovid here. I'm going to select it. And that's going to set up this game instance file as our game instance file going forward. And that's it for creating a game instance. Now let's go ahead and do our save game. So in our core folder again, I'm going to create a new folder, and this one's going to be named as save game. Now inside of here, I'm going to right click and create a new blueprint class, and this would be of type save game. And now we're going to select it. I'm going to name this SG for save game underscore necrobit. Inside of the save game, we need to now define what variables you want to save. At this given time in our game, we have our backpack structure and also our loadout structure, which is basically all the equipped weapons. And this is what we want to save. So I'm going to go ahead and create a new variable. And this variable will be my backpack underscore struct. And this would be of type backpack, sBackpack. And then let's make sure this is an array because this is what we have it as. And then also our loadout underscore struct. And this would be of type s loadout struct. And then again, this should be a type array, compile and save. Now you can add as many variables as you want into this file, and then you can actually update it. And whenever you save your game, these are the information that we need to update before saving. So let's go ahead and close our save game file for now. I'm going to go ahead and open up my game instance. Now, right off the get-go, the game instance does not really have any type of functions inside of it. There's no begin play or anything like that, just an empty file. And now we need to start defining this game instance as we would like. We're going to do a majority of our save game communications using interface. So let's go ahead and create an interface for that. So in our content drawer, let me go ahead to our interfaces folder. Here, I'm going to go ahead, right click, go under blueprint, and then select interface. And this one, I'm going to name it as BPI underscore save game. Now this interface is going to hold all of the functions that we're going to be calling for saving the game and loading the game and all such. So let's go ahead and open this up. Now the first function is obviously, we want to save the game, right? And then we have a second function, which is going to be our load game. Now there are going to be some inputs in here, but before I add the input, let me explain something. If you go to your necrobit, let's go ahead and add that interface. So under class settings, implemented interfaces, I'm going to search for BPI save game. Unreal Engine actually comes with built-in functions to save the game. For example, if I search for load game, so I have two options here. I have the async load game from slot, and I also have the load game from slot. Same for save game. There is a async save game to slot, and you have your save game to slot. Both of them has the exact same functions, but you need to understand the difference between an async load and save and also a normal load and save. Now, a normal load and save is an instant load and save. It's going to instantly load all the data, and it's going to instantly save all the data. It's beneficial to use these load game and save game when you're like at a start of a game or at the end of the game when the player is ready to quit or something like that. It's better to do so because the bigger the data, the longer this is going to take. And you don't want this data to be interrupted while it's being saved and such. So you want to have that specific timelines when you want to use a quick save, like a one-shot save. Now, async, on the other hand, think of this as a checkpoint. This save function actually runs in the background while the player is still playing the game. So for example, if I pick up a weapon from the ground, I don't want to really save the game to slot. I know it's going to happen instantly, but I would rather just have it happen in the background while the player is still doing all of the other things, because I know the game is going to be really heavy in terms of resources. So I don't want to add another process on top of it. So this is where I would go ahead and do an async, so the save is happening simultaneously while the player is still playing. In the games that you have played, you would see the autosave feature. The async is the autosave feature. That's what it is. We're going to be using both of this, and we're going to be using a Boolean to determine if we're going to do an async save or if we're going to do a normal save. So for that, in our BPI save game, I'm going to go to my save game and do an input, and this is going to be named as async. And set this to Boolean, and same for load game. I'm going to go ahead and say async. There you go. So compile and save this. Now let's go ahead and do the actual function. So let me delete this. We're going to bring this back in again, just a moment. I'm going to go ahead, right click on the load game, implement this event. Let's do the load game, and then we're going to do the save game right after. Now, when we load the game, first what we need to do is we need to run the function to check if there's an existing load. If there's existing load, we want to make sure that we always load that existing load and not create a new one. So we're going to go and search for does save game exist. Now this comes with Unreal Engine. So we're going to do this check first before we decide if we're going to do async or no async. Now the slot name, we need to determine what the slot name is. You have to type it in. I like to just promote it to a variable and then just name this as slot name. And if I compile, I'm able to now name the file. So this is the name of the file that you will have it locally on your computer. So I'm just going to name this as game1. Compile and save it. So now we have the slot name, and user index is going to be 0 for now because we're not doing a multiplayer game, it's a single player, so we can just leave it as user index as 0. Now we're going to do a branch, and we're going to now do a true or false. Now, if the save game exists, then we want to go ahead and load that save game. If the save game doesn't exist, then we want to go ahead and create a new save game. So let's go ahead and do the false first. So here I'm going to go ahead and say create save game object. And this is going to ask me for a save game class. And this is basically going to be our save game file, which is our SG Necrovid. So if I go ahead and check, there's SG Necrovid. So I'm going to select that as my save game class. And this is the file that we're going to be using to saving all of our data. And now I want to drag this return value and I'm going to promote it to a variable. And then I'm going to go ahead and name this as save game underscore ref. So now I have created a reference to that save game file. So this will now create a save game file if the save game doesn't already exist. Now, if the save game does exist, then now we need to check to see if we want to do a async load or you want to do a normal load. So I'm going to drag off of this async and I'm going to do a branch and connect this to true. If a load game does exist, and if you want to do an async, then here we're just going to go ahead and say async load game from slot. And here the slot name, we can just drag and connect this here. Index, we're going to leave it as it is. And async load also notifies us when the load is completed. So if you're playing a little image on your screen, like a little spinning wheel or something saying auto saving, once it's completed, then this is kind of like your notification to kind of like go and get rid of it or notify the player, hey, we just saved the game in the background for you or something like that, right? Now, I'm a huge fan of implementing interfaces and communicating with the interfaces, but unfortunately until this time I haven't really figured out a way to communicate with the save game file using an interface. So unfortunately we're going to do a cast. It's not going to hurt your game in any way. It's very minimal, it's very negligible, so you don't really have to freak out or anything like that. But we're going to do a cast here. So off of this save game, we're just going to go ahead and cast to our sg underscore necrovid, which is our save game file, and then take that SG Necrovid, and we want to now promote this to a variable, but we don't want a secondary variable. We want to use this as our existing variable. So drag our SG reference and then plug it in here on cast found, and then plug this as our save game reference. That's it. This is how we load the game. And now let's do the regular load. So if it is not an async, then we're going to go ahead and say load game from slot. There we go, this one. So this is the non-async. And again, slot name will be the same. So I'm just going to plug this in here just like so. And the return value, again, we're going to do the same casting. So I'm going to go ahead and plug this in here. And the return value, I'm going to connect this to the object. And that's going to now set up our new reference. So either way, we have now set up our save game reference in our game instance. And we have also created the function to load the game now. So I just quickly commented it to notify that this is going to be our load game function. So let's do our save game. Our save game function is very straightforward. Here, we're going to do a branch and we're going to check. Do you want to save it as an async? Like, do you want to save it in the background, or do you want to save it like at the end of the game, or like do a one big shot save here? So we're going to go ahead and do async save game to slot. And if async is true here, we're going to connect this here as such. And the save game object, we have a reference here. So we're going to go ahead and plug this reference here just like so. And then also the slot name. We're going to plug it in here. User index is going to be the same. And if it is false, let me move this out. If it is false, then we're just going to do a normal save game to slot. And we're going to plug in the same game reference and the slot reference here, just like so. That's it. There's nothing else you need to do here to save the game. It's pretty straightforward as it is. So now I'm going to do a comment on this. Now, when you start a game, the game instance is one of the first few files that actually triggers before your player character file or your level file or anything actually triggers. So right when the game starts, we want to go ahead and load the game data. Right now, we don't really have a menu system where the player is able to choose their game loads or game saves. So we're gonna actually go ahead and manually trigger a load as soon as we start the game. Game instance doesn't really have an event begin play. Instead, it actually has a event init. It's basically event initialize. Here, we're going to go ahead and call in this event load game. So I can just drag off of this and search for load game, and I should have, this is actually from the interface. I don't want to call this. I want to call it as a function within the game instance. And I'm not going to select the async. It's going to load as it is. All right, so now we need to update the information from our player character to our save game file. Now, we don't want to communicate to the save game file directly. We want to send all of our information to our game instance, and we want the game instance to communicate to the save game file because we've already done the casting here at game instance. So the game instance knows all of the information and has direct communication to the game save file. So we can have our player character just talk to the game instance, and then the game instance will take care of the rest of it. So first thing that we need to do is to create a function to save the information from our backpack and from our loadout to the game instance. So we're going to go to our BPI save game, and here I'm going to go ahead and create a new function, and this would be update backpack data, and this is going to have a input, and this would be type backpack underscore struct or backpack underscore data. This is going to be the name of it, and this would be of type s underscore backpack of type array. All right, just like that, compile it. And then now we need one for the loadout. So we're going to call in update loadout data. So the input is going to be loadout data, and it's going to be of type s loadout struct, just like so. Now we need to implement this function. So first, let's do the function in our game instance. So in our game instance, I'm going to go at the very bottom here, and I do have the update loadout data and update backpack data. So let's go ahead and implement both of these functions here, just like this. So I'm going to first get the reference of the save game file. And remember, inside of our save game file, we've already created these two variables. So I'm going to actually set these two variables using this interface function. So in our game instance, and drag off of our save game reference, and I'm going to go ahead and say set loadout struct. And when we had the event update loadout data, I'm going to go ahead and connect this here just like this, and then connect the loadout data in here. And same thing, drag from the save reference file, and we're going to say set backpack struct, and this is going to be the same thing, connected here to the update backpack data, and then connect this to the struct. Anytime your loadout data or your backpack data function is called, we want to set it, and then immediately we want to go ahead and save the game as well. So drag off of this, and we're going to call in the save game function, which is going to be the function, not the class of the interface. We're just going to call in this local function, which is this right here, event save game. And this, we're going to make it as async. So anytime the player picks up the weapon, we want to update the loadout data, and we want to do the save behind the scenes. We don't want to stop the game to save the data. We just want to save it behind the scenes. And that's why I have selected async here. So this is basically the function to update the backpack and our loadout data. That looks good. Now let's go ahead and implement these two interface functions. So in our third person character, I'm going to go ahead and edit my backpack here. And here I'm going to create a new function, and this would be update underscore save game file. Compile, and then this is going to be very simple. Our Unreal Engine already comes with a standard function to get a quick reference to the game instance that is being used. Again, this is not a direct reference, it's just a soft reference. So if I go and search for get game instance, I should get this node. This will communicate to the game instance, or we can use our game instance as a target. So here we're going to go ahead and use the game instance as a target and call in the function update backpack data. Let's go ahead and call it in just like this, and then drag in our backpack struct and then connect it here. So every time you call in the update save game file in your backpack, this is going to go ahead and communicate with the game instance, and then call in this update game data. It's going to update backpack data, and it's going to go ahead and set that variable in your save game file just about here. And then it's also going to save the game. Now let's go ahead and do that for the loadouts as well. So in our loadouts, we're going to have edit BPC loadouts, and then I'm going to create in a new function. And this is going to be, again, update underscore save game. Do the same thing. We're going to get the game instance. Here, I'm going to call in the update loadout data message. Make sure it's a message. And then let's go ahead and plug in our loadout content here. Good. Compile and save. So let's start implementing this update save game function into our different functions. So there's only two functions in our loadout that we want to actually implement this. First is adding the weapon. Every time a weapon gets added, we want to call in the save game. And then also whenever we remove a weapon from our slot, we also want to call it in. In our add to loadout function, at the very end, just before we do the return node to close off this function, I'm just going to go ahead and drag in this update save game and call it in just like so. And same here, we have another return node. I'm going to go ahead and call this update save game and then compile and save it. And then the remove weapon from slot, we want to do it here as well. Again, just before the return node, we want to go ahead and drag in this update save game, let it save the game, and then close off the function. That's all you got to do. Now let's go ahead and close our loadouts. And then in our backpack, we're going to do the same thing. Wherever we add weapons or whenever we remove a weapon from our backpack, we want to go ahead and save our game. So in the add to weapons function, I'm going to go just after we do our pickup feed, I'm going to go ahead and drag in this function, update save game file. And then again, add to backpack items. At the very end, I'm going to go ahead and call in the update save game file, just like so, just after the feed. And then where I have remove from backpack weapons, here I'm going to again call in the update save game file. So wherever you want in your game, whenever you make a change and you want to now save the progress, you can just call in this update save game file within your backpack or your loadout, and that will then update the game and save the file for you. Now we have done majority of the work. So the only thing that we need to do here is to initialize this. Our game instance already can save the file and then also load the file. Now our backpack can actually communicate to save the file, but it cannot really load the file. We don't really have a function to load that information back when the game starts. So we're going to use our third person character to take care of that. Right below our enhanced action, I'm going to create a new function here, a custom event, sorry. And this is going to be named as initialize underscore character. Right, very simple function. This is going to go ahead, and now we're going to use this to get the information from our game instance. We're going to use our game instance to communicate to our save game file to get information from these two structs. So for that, we need to have a new game interface function. For that, we need to have a new interface function. So we're going to go to our BPI save game, add in a new function, and this would be get underscore player data. And this is going to have two outputs. The first one is going to be our backpack data, and this would be of type backpack struct array again, and our loadout data, and this would be of type loadout struct, and make sure that's an array. Compile and save it. Now, in our game instance, before we go ahead and implement the initialize character, in our game instance, let's go ahead and implement this get player data. So I'm going to double click on this get player data. Because it has an output node, you notice that the interface function is actually gray color or white color. It's not yellow like every other event that we have been implementing all this while. In our get player data, I'm going to drag in my save game reference and do a get, and then right click on it, and let's make sure it's converted to a validated get, because we don't want to get any errors just in case the save game reference does not get properly referenced in our game instance. We want to make sure that it doesn't throw any weird errors. So only when the save game reference is valid, right? We want to now drag off of the save game reference, and we want to get our backpack struct, and then also get our loadout struct. Connect the backpack struct to this backpack data, and the loadout struct to the loadout data. And then make sure it's connected only when it's valid. If it's not valid, then we're not really getting any information back. So now in our third person character, we can now call in that function. So we're going to get a target reference for our game instance. Drag off of this, and we're going to say get player data, send it as a message. And now you're going to get both of the information for the backpack data and the loadout data. You can create a separate function to just get the backpack data or just get the loadout data. In our game, we're going to go ahead and load both of the information because our backpack and our loadout is kind of working together in conjunction. So it's okay for us to get both the data at the same time. And now we're going to drag in our BPC backpack. And we're going to go ahead and set the backpack struct. So this is how we're going to update the information in our backpack. So let's drag it and connect it here, just like so. And the same thing for the loadouts. We're going to go ahead and set the loadout contents and the loadout data. I'm just going to plug it in here. Just like this. This is all we have to do. And the last thing that we will need to do is to call this initialize character function. I do not want to do it off of event begin play. I actually want to load in the data before event begin play. Right? So the function that runs after game instance but before it begin play is actually event possessed. So this is when the character gets possessed by us, right? Or the main character. Off of here, I'm going to go ahead and call in for initialize character. Just like this. I'm going to go ahead and pick up a pistol, and pistol actually is in my inventory. Let's go ahead and close it. And everything seems to be okay. Let's play again, and if I open up my inventory again, the pistol is there. And let's go ahead and pick up a AR rifle as well. And there it is. And now I can go ahead and equip this pistol in, let's say, the slot. And again, if I go ahead and close the game, if I open it up again, and if I open up my inventory, the pistol is there, and the AR4 is still over here. So let's go ahead and equip the AR4 and unequip the pistol. So it goes back into my inventory. Close it, and let's go ahead and play. And there it is. The weapon is sitting just perfectly fine, exactly where I wanted it to be. So there you go, folks. I know it's a little long video here. Sorry about that. But I wanted to make sure that you truly understand how to save the game because it's truly a logical process. You need to go step 1, 2, 3. You cannot really skip any step or else the data won't really load properly. And you need to properly initialize all of your files as well. So that's why it took a little extra time to ensure that you understand how the load game works. Let me know how it goes for you in your game. For those who are wondering, if you go to your project folder where your project is actually saved, it's usually in your C drive or whichever drive that you have installed your project into. Epic Games, projects, and then wherever your project name is, there should be a file name, folder name saved. If you open it up, there's actually a saved games folder. Inside of here, there's our game 1. This is the name of the slot that we set up. So that's where the file is. So if I go ahead and delete this file, and if I go ahead and press play, and if I open up the inventory, everything is fresh. There's nothing there. And if let's go ahead and pick up this AR4, and it should be in my inventory. And if I press close, and if I open that folder again, I have my game save again one more time. So this is where you have your file saved. I hope this helped, and I'll catch you on the next one.